let's talk about Cartesian product. Cartesian product is generally taken between two sets. You can take it between two or more sets, but then here let's restrict ourselves to Cartesian product between two sets. Let us say we have a set A equal to 1, 2, 3, and we have a set B equal to A comma B. Okay, now what do I mean by Cartesian product is, it is represented like this. It is also sometimes called as cross product or Cartesian product. So when I apply Cartesian product between these two sets, then we are going to get set of ordered pairs. So ordered pairs means one element will come from A and one element will come from B. For every element in A, we are going to pair it with the element in B. But then since we are writing A into B, it should always so occur that elements of A should occur before elements of B. For example, in this one, we are going to get 1A and then 1B. For every element in A, it is going to be paired with every element in B. 1 is paired with A and B, isn't it? And similarly 2 will be paired with A and then 2 will be paired with B, and 3 will be paired with A and 3 will be paired with B. Each element in this one, it is called as ordered pair. It is different from a set. A set is an unordered set of elements, right? But here it is ordered. This order is important. 1 comes from the first set and A comes from the second set. In every ordered pair, the first element comes from the first set and the second element comes from the second set. It is called as Cartesian product or cross product. In this case, the number of elements in A, the cardinality of A is 3 and the cardinality of B is 2. That is why the cardinality of A into B, they say, this set, the cardinality happened to be 6. So in general, if cardinality of A equal to M and if cardinality of B equal to N, then cardinality of A Cartesian product B is going to be M into N. I think you got the reason, right? The reason is every element here is going to be paired up with N elements here. Therefore, one element is going to give rise to N elements in the result. That is why it is going to be M into N elements in total. So this is called as Cartesian product. Now a relation is generally we take the relation from Cartesian product. So a relation is nothing but subset of the Cartesian product. Assume that this is the Cartesian product, isn't it? Now I can define the relation like this. I can take a subset from this and I can say that it is a relation. So I can write R equal to, I can take some of the elements, let us say 1A and 1B, right? Now this is a subset of this Cartesian product and therefore it is a relationship, okay, or it is simply relation. And now we say that these two elements belong to the relation R. Sometimes we write even like this, 1 is related to A. Even writing like this means that the element 1 comma A belongs to the relation R. Or we can form one more relation, let's say R dash is a relation, and I can say that R dash equal to 1A, 2A, something like this. Randomly I am taking it. It doesn't have any sense. Later we shall see some relations with meaning also. So here also I have taken some of the elements from A cross B and I have formed the relation. Got it? So what does it mean? A relation is nothing but a subset of the Cartesian product. You can take any subset, it will be called a relation, and the elements of that are said to belong to this relation, or one is related to A through the relation R1. It can be written like this, R dash A. What does it mean? 1 comma A belongs to the relation R dash. So whatever I am discussing here is just about a simple point. First, in order to define a relation, we have to define the Cartesian product. Once the Cartesian product we get, then the relation is nothing but any subset of the Cartesian product is called as a relation. Now, probably you must be wondering how many relations may be possible. So that depends again. Now, I told you that the sets can be finite or infinite. In case if the sets are infinite, then the Cartesian product is also going to be infinite. If either A or B or both, if both of them or one of them is going to be infinite, then the number of elements in the Cartesian product is also going to be infinite. Then a subset of it may be finite or infinite. Then we are going to get infinite number of relations. But then let's restrict ourselves to finite sets. Now if we just consider the possibility that A and B both are finite and both are containing m elements and n elements, then how many elements are going to be present in A cross B? It is going to be m into n. It means that the cardinality of the Cartesian product is m into n. If these many elements are present in the Cartesian product, then how many relations can be formed from that? We know that every relation is nothing but the subset of the Cartesian product, isn't it? Every relation is a subset of the Cartesian product, and if the number of elements in the Cartesian product is going to be m into n, then how many subsets will be possible? We know this. If n elements are present in a set, then the number of subsets is going to be 2 power n, isn't it? Similarly, in this case, the number of relations is going to be 2 power m into n. So what is it? If A contains m elements and B contains n elements, then the number of relations possible is 2 power m into n. How did I get it? Because the Cartesian product is going to contain m into n elements, and the number of subsets present or that we can form from that set is going to be 2 power m into n. Therefore, this is the total number of subsets which can be possible from the Cartesian product, which is nothing but the total number of relations. Now these relations can be classified into various types. We shall discuss all the types of relations like reflexive, symmetric, antisymmetric, transitive, equivalence, poset, all this. We have all these in the syllabus, and we shall do a lot of questions on that. Before going ahead, let us explore the concept of relations a bit, like how to form a relation and how to represent it, how to identify whether an element belongs to the relation or not. Let's explore it a bit with some few examples, then we can go to the types of relations. In exam they are going to ask you about the types of relations. Okay, fine. Now let's see some examples of relations. We can form a relation like this. Let capital R, where capital R is the representation or the name given to this relationship, okay, relation. So capital R is a relation in such a way that capital R equal to x comma y belongs to z cross z. So what does it mean? Z is nothing but set of all integers. So we are taking a relation which is subset of z cross z. We know that z is infinite, right? And z cross z is also infinite. So we are taking a subset of this infinite set, and we know that a subset of an infinite set can be finite or infinite, right? So we don't know whether R is finite or infinite. Let's see. In such a way that x is less than y, then what do you understand from that? So we are taking every possible pair. Z cross z is nothing but set of all possible pairs of integers, and now relation R contains, of all these possible pairs of integers, relation R contains the elements in such a way that x is less than y. So example 1. Now can you tell me some examples, or at least can you give me some elements which are present in R? So what is it I am trying to say here is, R is a relation which is a subset of the set z cross z, where z is set of all integers. So what does it mean? We are dealing with set of all possible pairs of integers in such a way that the element will be, the pair will be present in the relation whenever x is less than y, which means if the first element is less than second element, that will be present in R. So it is going to be infinite for sure. Now what we want is you to understand what are the elements that will be present in this. If I give you an element, you should be able to identify whether this element is present in the relation or not. Okay, see this. So first element should be less than second element. What do you think about 1 comma 2? 1 comma 2 is definitely related to it's definitely present in the relation. or we can say that 1 is related through or to 2, which means I can even write like this. Both are same, right? And likewise, you can get infinite number of elements. It is not finite, therefore we cannot write all the elements, but then I am just giving you few. So what about 2 comma 3? Yes. What about 1 comma 4? Yes. All these belong to the relation R. What about this element 4 comma 3? 4 comma 3 doesn't belong to R. The reason is because 4 is not less than 3. See, we want all the elements which will be present in the R will be of type first element has to be less than second element in the ordered pair. First element should be less than second element. In this case, first element is less than second one. First one is less than second one. First one is less than second one. But here we don't have such relation. Okay. Now let's look at example 2. What does example 2 say? It is also the same kind, which means it is a subset of set of all pairs of integers, because it is a Cartesian product between two sets of integers. Therefore, R is definitely a subset of set of all pair of integers. We are dealing with set of all pairs of integers in such a way that the difference x minus y is even. If x minus y happens to be even, then the element will be present in the relation. Therefore, tell me about this. What about 1 comma 2? Will it be present in the relation or in example 2? It will not be present. The reason is, if you take 1 minus 2, the output is 1, which is odd, right? Therefore, it does not belong to OR, right? Or we can even say 1, 2, it does not belong to OR. Now, what about 1 comma 3? Yes, 1 comma 3 belongs to OR. The reason is, if you find out 1 minus 3, the result is 2, which is even. Therefore, it belongs to OR. What about 1 comma 5? Yes, it belongs to OR. Likewise, again we will get infinite number of elements here. Therefore, I am not writing all of them. Now let's look at the third example. In third example, there is a finite set A and finite set B. Now what can you say about the Cartesian product? It will be finite, right? And now they are saying that R is definitely a subset of A cross B in such a way that all the elements whose sum happens to be 3. If you form A cross B and if you take each ordered pair and if you sum the elements in the ordered pair, if the sum happens to be 3, they will be present in the relation. Can you evaluate it? So just to evaluate it, you have to find out all the Cartesian products. See this? Let's talk about example 3. So in example 3, A is given and B is given. Find out A cross B first. A Cartesian product B. Then what do we get? We are going to get 1 comma 1, 1 comma 2, and then 2 comma 1, 2 comma 2, 3 comma 1, 3 comma 2. We got 1, 2, 3, 4, 5, 6. Okay, 4 comma 1, 4 comma 2. So we got totally 8 elements here. So why 8 elements? Because in A there are 4 elements and in B there are 2 elements. So totally we are going to get 8 elements. Out of all these 8 elements, we are going to take out the subset which will be present in R. That is what is given here. So R contains elements of form x comma y which belongs to A cross B, which means definitely we have to choose some of the elements of this or all of them if they satisfy the condition. What is the condition? X plus y has to be 3. Now you take each pair and sum them up. If the sum happens to be 3, then you add them to R. Therefore, since it is finite, I am just writing out all the possible elements. If it is infinite, I cannot write it. That is why in the previous examples, I just taken few elements and I asked you whether they belong to relation or not. Okay. Now see this. In this one, what can you say? So, first one, 1 plus 1 is 2. Therefore, it is not present. And 1 plus 2 is 3. So, yes, it is present in R because that is the condition given. If x plus y is equal to 3, then include it in the relation R. That is why I am including it, right? And what about this third example? 2 plus 1 is 3. That is why I am taking it. What about fourth example? It is not present, right? No, 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 no. Therefore, only these two elements are going to be present in R, right? So, if you observe this, we have seen some examples where a relation can be infinite or a relation can be finite. Isn't it? In these first two cases, relation is infinite, and in the second case, third case, relation is finite. And moreover, a Cartesian product can be infinite or a Cartesian product can be finite. And moreover, we have seen some relations which are defined on the same set, isn't it? So it is a relationship, it is a relation, but then it is depend on the same set. We are taking only single set and we are doing that. So in this case, in third example, we are using two sets. Then we can say that R is a relation from A to B, or we can say R is a relation from A into B, right? So that is terminology. We can say R is a relation from A to B, or R is a relation from A into B. Sometimes what happens is, most often we'll be interested in the cases where R is a relation from A to A, which means a set A will be given, and then we are supposed to find out A into A, and then they'll talk about the elements which are present in this, and they try to form the relation R. Okay, and based on that we'll talk about the properties of R. Fine. So just try to understand this. A relation need not be finite always, it can be infinite. A relation need not be defined on two different sets, it can be defined on two same sets, and these sets may be finite or may be infinite, which means there are no restrictions as such. Got it? And so one important point here is, whenever they didn't say that there are two sets, then it means that they are working on the same set. If they say that R is a relation from A to A, then don't get confused. It means that they are talking about this A into A. For example, A can be like this. A can have elements 1, 2, and then they can say R belongs to, or maybe R is a subset of A into A. What does they mean? What does it mean? We have to find out all the possible pairs A into A, that Cartesian product, and then find out R. Got it? Okay, anyway, once you understood how we represent this and how to find out whether an element belongs to a relation or not, now let's try to find out what are the types of relations. That is an interesting question. So one thing is for sure, a relation is nothing but subset of Cartesian product, right? And in this case, R is said to be a relation from A into B, right? And if an element is present in R, if an element like A comma B, then we can write like this: A comma B belongs to R, or A is related to B through R. That is what we can write. These are all the notations. So once you are good with these notations, let's try to explore the types of relations. That is where we get the gate questions. Whatever I discussed here is just to introduce to the concept, but then the questions, the main questions we get in gate will be from the types of relations. Okay, we shall see that.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have, you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.